Okay, so today we're going to be talking about isosceles and equilateral triangles, and we will be dealing with some theorems. And so if you have an isosceles triangle, there are two congruent sides and two congruent angles. And so the definition would be if you have a triangle with at least two congruent sides. The legs are called the congruent sides. Okay, so just like the legs of a right triangle are the sides of the triangle who form the right angle, these legs right here are the sides that form the vertex angle. Okay, so the congruent sides are called the legs, and the non-congruent side is called the base. Okay, so it's possible that all three sides are congruent, but the non-congruent side would be called the base. And the vertex angle is the angle between those two bases. Okay, so vertex angle is the included angle or the angle between the two legs. And it's always stated in the middle when you name the isosceles triangle. So you would start with one end of the leg, and you would say the vertex angle next, and then you'd say the other end of the leg. So in this case, you would call this triangle. You could write the word. You would do ABC, or you could do CBA. Now notice B is the vertex angle, and that has to be in the middle. And the way that you differentiate an angle from a triangle is you use the word triangle in front of it or a picture of a triangle in front of it. So whereas an angle has the word angle or an angle in front of it. So those are some basic things. Also, the base angles are going to be the angles across from the congruent sides. And so the base angles will be congruent, just like the legs are congruent as well. Okay, and the vertex angle would be the non-congruent angle. Okay, assuming that you have a true isosceles triangle which has two sides that are congruent and one that is not. And so equilateral triangle. Okay, wait, the theorem. Okay, if you have an isosceles triangle, okay, with two sides congruent, then the angles opposite those sides will also be congruent as well. Okay, so that's isosceles triangle theorem. We can do the converse. If two of the angles of a triangle are congruent, then the two sides opposite those angles, that's those sides, opposite those angles will be also congruent. Okay. Okay, so if two sides of a triangle are going to be congruent, their opposite angles will be congruent, and also the converse is true. If two angles are congruent, then their opposite sides will also be congruent. Then the sides opposite those angles will be congruent as well. Okay, next part would be equilateral triangle. And if you've got three congruent sides, well, then all three angles will also be congruent. That means they're going to each be 60 degrees as well. Okay, so so these are corollary kind of results. And so the theorem for isosceles actually holds for this as well. But if three sides of the triangle are congruent, then the three angles opposite those congruent sides will be congruent as well. I'm using my finger, you can tell. It's not writing very well. Okay. That's a congruent symbol. It looks like, I don't know, an elephant, a bad one. And so if three angles of a congruent triangle are congruent, then their sides opposite them will also be congruent as well. And then if three angles of the triangle are congruent, using the triangle sum theorem, each of those angles will be 60 degrees. So kind of results of having an equilateral triangle. Okay, so let's do some math about these theorems. Okay. Can you find these measures of the angles given that AB and CB are congruent to each other? Okay, so we'll mark that. Well, if those two sides are congruent, then we know their opposite base angles will be congruent as well. And base doesn't mean on the bottom, it just means directionally across from the congruent sides. Okay, so that we can do some subtraction. Linear pair theorem says that if you subtract 115 from 180, you're going to get this measure right here, and that's going to be 65 degrees. Because they're isosceles triangles, this angle right here will also be 65 degrees. And if you subtract those two from 180, so x plus 65 again is equal to 180. And you subtract those 65s from both sides, you get x is equal to 50 degrees. Okay, so that means this top vertex angle is going to be 50 degrees. And technically all the corners are called vertices. However, we call it a vertex angle because it's the non-adjacent angle in an isosceles triangle. And so let's put these in our chart. So that means that BCA, the measure of angle, notice that's the proper way to put it. The measure of BCA is equal to, and please make sure you put a degree sign. This will be 65 degrees, okay? And the next one will be 65 degrees as well, because those are the two base angles. And then the vertex angle, which is the one at the top, the one that's across from the non-congruent side, is going to be 50 degrees. Okay. Again, please remember, I could lay any triangle on its side where these two are the basic, the legs, and this would be the base, okay, which would be non-congruent. So that would mean the vertex angle would be across from that, and then the base angles would be these two angles right here. Okay, so the base angles may not be on the bottom, and I think that's an important thing, is the base angles are just the angles that are opposite from the congruent sides. Okay, moving forward, we've got a little bit more math that we can do. Okay, so given a circle, okay, and if we look at, so why are we doing circles? Well, within a circle, we can go to the center, and we're starting to put some shapes together. And what would you call the length FG? We'd call it a radius, okay? Well, what would you call the length FE? The segment FE. Well, that's also a radius. In a circle, part of the thing that makes it round is that the radius, the distance from the center to any point on the circle, that is called the radius. It is always congruent to itself. So therefore, we have two congruent sides because they are basically radii of this shape. So those two should be marked the same. So they're congruent. So that means that the opposite angles from those congruent sides will also be congruent to each other. So that means if you do x plus 100, using the triangle sum theorem, you get 180 degrees. Subtract 100 from both sides, you get 2x is equal to 90. Divide both sides by 2, you get x is equal to 45. So that means that those two angles are going to be, wait a minute, did I confuse it? Well, if you subtracted 100 from 180, you get 80, not 90, and divide it by 2, you get 40, not 45. So this is 40 degrees, and this is 40 degrees as well. And then EFG, would be 100, and that's what they gave us right here. Okay, so, just kind of saying, well, what do I know? What do I see? They didn't tell us much, but they gave us a circle. And if radii are congruent throughout a circle, then you have an isosceles triangle there. So that's a good thing to have. Now, here's another thing. It looks like we have an isosceles triangle, and we do. Notice those two sides are congruent. But it says, please solve for x. Well, I've got an issue, okay? We know that this side right here, this angle right here, and this angle right here will be congruent. So if we do y plus 60 is equal to 180. Now, some of you guys might already see this. If one of those angles is 60 and you have 120 degrees to divide evenly between the other two, both those angles have to be 60 degrees. And so it says it's an isosceles, but secretly it's also an equilateral triangle. Okay, and so if you solve this equation, you get 2y is equal to 120, so y is equal to 60. So that means we do have an equilateral triangle, an equal angular triangle as well. So we can erase this and say, you know what, all three angles are really 60 degrees. And so they were trying to trick us, okay? And so all three are 60, so that means all three sides are congruent. They said, please solve for x. Well, originally, we would have set the two sides that say that they're congruent equal to each other and solve that equation, but they didn't tell us both of those, did they? But they did tell us 60, and that was a clue to say, actually, we have an equilateral triangle, so we can set the other two sides congruent to each other because it is actually an equilateral triangle. Okay, so here we go. If we subtract 3x from both sides, we get x. If we add 4 to both sides, we get 12, so x is equal to 12. So that should be that. Now you could, evaluate each side and find the length of each side, and each side should be congruent. And if it's not, then you botched it. Okay, the next one says, hey, I have an isosceles triangle. Well, isosceles triangle means that if two sides are congruent, then their opposite angles will also be congruent to each other. So this has to be x degrees as well. Those base angles are the angles opposite from the isosceles sides. Congruent sides have to be congruent. So if you do x plus 3x equals 180, you're going to get 5x equals 180. and you're going to get x is equal to 36. And if they ask you to figure out, okay, well then tell me what each angle would be, the bottom two angles would be 36, and then the top one would be 3 times 36, whatever that answer is going to be. Okay, and so you can evaluate that as appropriate. The next question is a little bit tricky, so I'll try to phrase it in a way that will help you. And then we get to do a proof. The proof is not bad. I'm not going to lie. It's not bad. So this next question, though, let's kind of say they use this diagram and they use it for multiple reasons. So we're going to have to look at it, mark what we know, and then say, in light of that, what would we know? Okay, so you're going to kind of write something and then erase it. So you may not want to use pen, this first time around. So if RV is congruent to RT, what two angles have to be congruent to each other? It looks like you're looking at the whole big triangle, doesn't it? Well, the opposite angles, the base angles would be these two angles here. So you would say angle RVT, and then also angle RTV. Okay, so if those two sides are congruent, then those two base angles have to be congruent. So now I'm going to erase it and say, okay, that was really fun. Let's try another problem. Okay, so I erased that, and they said, okay, what about if they say, okay, if this is so much fun, if they give us angle STV, okay, so STV, so that's this little guy right here. If this is congruent to SVT right over here, then what two sides have to be congruent? So if those are the base angles, okay, which two sides have to be congruent? So the sides opposite from them, okay, notice we're talking about this triangle right here. So the sides that are opposite would be SV and ST. So SV segment and ST. Okay, so we're saying what triangle we're talking about and what sides would be opposite from those two base angles. Okay, so that was super fun. Let's erase it. Let's try it again. Okay. How about what if we've got RS and SV that are congruent? So RS and SV, you're like, turn your cute self around. Okay, turn yourself. Okay, turn the paper. Be like, ooh, look at this. If those two are congruent, what two angles have to be congruent to each other? Okay, and that would be this angle here and this angle right there. Okay, and so I'm going to write it off to the side. So you could say angle SRV, angle SRV, and then the other one would be SVR, angle SVR. Okay, awesome. Well, that was a little bit weird. Okay, I'm going to turn this paper back. Okay. And then, okay, what if I've got, let me erase this. Okay. How about if SRT, so SRT is congruent to STR over here. Okay, let's turn the corner. Here we go. Then that looks like we've got these two sides that will be congruent. So it'd be ST and SR. So ST and SR. Okay, so sometimes you've got to turn the corner, label what you know, and then say, okay, based on that, what do I know from here? Okay, we did such a good job on that. And then we got just a proof. Okay, so let's look at this proof. So in this proof, we're trying to show that triangle BCD is isosceles, okay? Okay, so the rest of this proof is going to be about saying, I know that 2 and 4 are congruent. Okay, so let's mark those on our diagram.
Don't get mad at me, but I almost asked.
Okay, so this proof, if you label what you know these two angles are congruent, 2 and 4, and you know that these two lines are parallel. Okay, so we're trying to prove that this top triangle, BCD, is going to be isosceles. Okay, so that's what we're going to do next. Okay, so we're given those pieces and we're trying to prove that the triangles are going to be isosceles. And so I think the first thing is we're going to say AE and BD are congruent because it's given. Okay, and so I'm going to write given. Okay, and then the next thing is angle 1 and 2. These guys right here are going to be corresponding angles by the definition of corresponding. angles. And then my handwriting's bad because I'm writing with my finger, but my stylus is not working. The next part would be the angle 1 and 2 and 3 and 4 are congruent. Why? By the corresponding angles postulate. Okay, so if you've got parallel lines cut by transversals and you have corresponding angles, the corresponding angle postulate says that the angles will be congruent. So corresponding angles postulate. Okay, the next thing is angle 2 and 4 are congruent, and that's from given. Okay, so look up at your given. And then the next one says, okay, therefore 1 and 4 are congruent. That would be the transitive property of congruence. And actually the next one is as well. 1 and 3 would be as a result of that to be transitive property of congruence. And then, okay, here's the weird thing. If we know that 1 and 3 are congruent by the converse of the isosceles triangle theorem, we know that the segments CB and CD would also be congruent. So this is the converse of the isosceles triangle theorem. Okay, so the converse of that says if the angles are congruent, the segments across from them must be congruent as well. And then the last thing we're going to write is, therefore, triangle BCD is isosceles. Why? The definition of isosceles triangles. Why? We just said that those two triangles have two segments that are congruent. Two of the sides are congruent, so therefore we must have an isosceles triangle. So we did a proof. Good job. Thanks. Have a good day.